Okay, so the big aim here of this community is, of course, to understand and to appreciate the work that was done in machine learning, but also we realize that, okay, to move forward in AI, we need to have capabilities to represent inference. And inference, as I mentioned in the first half of the talk, inference can be a very complex process, and inference cannot be drawn only by using machine learning techniques, because the procedures that we use in logic, that we use in first order logic or model logic, they are highly complex. And if you take a naive approach to reason, of course, you have to confront issues of complexity and other issues related to the meta properties of logical reasoning, such as completeness, such as soundness, such as decidability, and so on. So, and in artificial intelligence, and more specifically in neurosymbolic AI, in order to confront these problems and to confront this line of research, there are many open challenges. One of the first challenges that we have in neurosymbolic AI is the proper representation of first-order logics. As you know, first-order logic is undecidable, and if you take a naive approach to represent first-order reasoning or relational reasoning, you are going to not to be able to develop sound systems, and in the end of the day, we will not be able to have explainable systems or interpretable systems, because when you are dealing with first-order logic, decidability is a key issue. So to develop a system that balances learning and reasoning is still a big challenge, is still highly complex. The other problem that we confront in terms of reasoning and machine learning in neurosymbolic AI is how to represent common sense knowledge. Common sense representation and common sense reasoning remains a big challenge in artificial intelligence. And another associated problem that we have to confront when we deal with common sense reasoning is the combinatorial explosion of possibilities that we have when we represent common sense knowledge of agents. For instance, considering the example that I mentioned in the first half of the talk, when you are crossing a street, for instance, if you have to plan the way you cross a street for a robot, for an agent, you already have a large number of possibilities to represent from the information that we gather from the environment. And perhaps the best possible way to confront the problem of combinatorial explosion is to understand how machine learning systems deal with learning NP-complete problems. This is one of the approaches that we are investigating as well. Perhaps we can draw some inspiration and some results from the representation of these problems in computer science, where you analyze the complexity of reasoning by drawing comparisons and drawing analogies with very complex problems that we bring from the theory of NP completeness. I'm not saying that we are going to represent common sense reasoning using the tools from NP completeness, but what I am saying here is that common sense representation, common sense knowledge is highly complex. You have many degrees of freedom. You have many possible combinations in situations that we are trying to represent. And there is a way of dealing with combinatorial explosion that comes from the theory of NP completeness. Perhaps there is a way of combining those two techniques. And finally, when we build AI system these days, we cannot ignore the fact that artificial intelligence is applied in every walk of life, in several application domains, in multiple application domains, and more we will have to build systems that can combine, let's say, the abilities of artificial systems and the abilities that we as humans present. And if we can put humans in the loop in AI systems, actually this is something that we have to confront in AI, is how to manage and how to have the best possible combination of artificial systems that deal with abilities that humans are not very good at, and to combine with our cognition, with the abilities that we have as humans to develop applications and to develop things that can improve the way that we live on the planet. In the end of the day, what we are trying to do here is to harness the power of human reasoning and computational reasoning and computational learning to build systems that combine both abilities. In the same way that we're trying to build neurosymbolic AI systems that combine machine learning and logical reasoning, we have to be aware that in this world, in the world that we live today, more and more we have human network communication between humans, between artificial systems, and we have to build systems that can actually communicate with humans in a sound way, in a transparent way, in a trustful way, in an ethical way.